Hello, welcome to another session for Python programming language. In this session, I'm going to be discussing Python programming language, especially the Python OS module. So first of all, let me just show you what operating system I'm running this Python version 3.6 or Python 2.27 earlier version, and how I just want to set up my environment to make sure that I run Python 3, the latest one, or a better version than Python 2.27. So in this case, if I just want to know what operating system I'm using, I clear my screen and I type in uname -a. I'm on a Linux operating system. The version of the Linux operating system, if I say cat os-release from the etc directory, it shows that I'm running Ubuntu 18.04.15, as you can see here. And if I just want to get more details, yes, obviously I can get that one. For example, later on I will show you that same commands, I can run it inside Python, that I will get the same information. For example, if I want to know my current working directory on Linux or Unix, you type in pwd. If you want to know who you are, you type in ID for identification. And who am I is also shows you who you're logged on from through SSH from the remote site. But if you type in who am I, all in one word, no space, it can show you the your user ID, in this case, Lutfi for myself. And if I just want to know, let's say, for example, my bash script, I could say get env um, and then password. Sorry, let me clear the screen. So I could say get end, not get env, get end for get entry. Let me type it correctly, get end, and then pass wd for password. And you can see all of them are there. So if I just want a specific user, I clear my screen and I type in get end uh, pass wd, and then in this case wlutfi for myself. I can see that I'm using /bin bash and then home is my home directory. So some other commands, I can get my environments by typing env, which shows all the global variables. If I want to get the global variables as well as local variables, a set command that will list all of them. But let's just do a get, let's see, let's do a env. Clear the screen here, and then do a env, and then grep -i pwd for print working directory. As you can see, there's two environment variable. One is called the old print working directory, and the other one is the new one, the current one. So if I just type in pwd, when I cd from another directory, the parent and directory that I logged in earlier was old PWD of programs, and from programs I went to Python. So now I have some scripts here that I could run. If I do a listing of these files, it's there. So I have two shell script and one two Python scripts. If I just want to see the contents of the Python scripts, I could do the Unix command cat -n os.py. That's a Python script. As you can see, the line numbers on line number 1, I'm using the pound shebang, which is the syntax to say that call the env in whatever environment variable I pass in this case, the name of the script Python. It will just spawn a Python interpreter as if I'm just running Python. And if I want to do Python 3, I obviously, instead of Python, I would do Python 3. And then this one, I just on line 3, I'm importing OS module. Then after that one on line 5, I'm looking at if OS dot name is POSIX, then clear the screen. If it was in T, for example, you would do a CLS for clearing the screen. So I check the validation to make sure it's portable operating system information exchange POSIX. And then as a result, I run the proper command for the Linux. And then print list of the functions. So when I do a dir OS, is going to be listed all the functions and methods that double underscore methods. They call it dunder or double underscore methods, and then also the attributes and modules. And then some of the functions I will later on explain. Here, I'm just also getting a help on the operating system OS module to see that what are the some of the functionalities of help. So if I type in just for this one, and then another one is p1.py. If I look at the contents of p1.py, let me clear the screen again and say cat minus n p1.py. In this case, p1 dot, sorry, not pi1, p1. So I mistyped the y here. I'm going to remove the y, and then that would display p1.py contents. So clearing the screen one more time and running the correct command. Here we just see that it is on line 1 again. I'm calling Python, and then after that one is I'm doing a print statement and saying that this is coming from the Python script. And then for item, using a for statement in range of 1 to 5, it's supposed to say this is line number 1 through 5. All of them will be printed on that one. But let's just look at what version of Python we have. So if I say which Python here, Python, it's gonna be pointing to the user bin Python. This one is the dash v dash version, you could say, or dash uppercase v, and then not sorry, not uppercase v, dash lowercase v, or dash dash. Oh, Python is mistyped. That's why. So let me just correct it first. Typo is not gonna be fine. You have to type it correctly. Python dash dash version should give you the version number, and dash uppercase V should also give you the same version. Python, sorry, Python dash V. My keyboard is a little bit rusty, so that one also give you the same one. But if I just run and then say which Python 3 I have, then you can see that I have also Python 3 on user bin directory. So if I say Python 3 dash uppercase V, it tells me that 3.69 is there. And then Python dash dash version would also reveal the same thing. And so at this time, I'm gonna just not run Python, because if I by default type in Python here, it's gonna get me to Python 3 because of my previous one that I had an alias for it. So if I just list my aliases, this is list of current aliases, but then you can see I have a Python syntax that it says that run Python 3. So if I just an alias the Python thing, and then just say alias and then type in Python, and then you can see right here, sorry, alias Python. It just shows that it's not alias. But now let's just add an alias. Before we add an alias, actually, in fact, we just do a Python. This time you can see it is dropping to Python 2.7.17, which is the older version that I don't want to run the older version. So I'm going to exit out of this one. You can do exit or quit to get out of Python interpreter and clear your screen. And then this time I'm going to create an alias, say alias and then I could call it Python is equal, and then I'm going to be pointing to, I don't have to say user bin Python, I could just say Python 3 because that is in my path. If it is on your path, echo $ path has it, then the user bin automatically, as soon as you say which Python, it will detect that one. So now if I just type in Python is equivalent to running user bin Python 3. And then that one is dropping me to 3.69, and that is good. As I said before, you can quit or exit with the function and it will get out of Python interpreter. So I got in and now I got out. Now let's just run this clear screen command and then look at star.py. Now I see that there's two files that I have with Python scripts, os.py and p1.py. If I say file star.py, it tells me that these are Python scripts. You can see that they're showing Python script. So and what does that mean? If the file p1.py is having the permissions, let me just type it correctly with p1.py. So let's just clear the screen. ls minus ld star.py. As you can see, the two files has the same permissions of read, write, execute by the owner, which is W Lutfi in this case, read and execute by the group, which is also W Lutfi, and read and execute by other groups and other members that are logged on the system or could be logging in later that could check. That means everybody that is on this system, they can run that program because the executable permissions is allowed and everybody can read it. But only the owner, which is W Lutfi, could write to it. And the write permission, this W means only the read, write, execute is for the owner. This one is read and execute for the group, as I mentioned, and then read and execute for others. No write permission. So if I just want to run this one, since it's a Python a script, I could just say p1.py, it will just execute the same command. And now if I just say cat minus n p1.py, you can see it is just on line 1, it is saying call the Python program to just execute these system calls or function calls or for statement to print out that one. So what does that mean? That means that I can just also type in Python 3 or Python there, and then just give the name of p1.py as argument to run it there. And that would produce the same output. And if I just do it without Python 3, because I already created an alias, that would also do it. And then some of the syntax, if you want to check the syntax of a print statement without parentheses around it with Python 2.27, and some of those ones were allowed, but with Python 3, you have to have it like a function with the left parentheses there. So these are the options that we have. Now let's look at the other Python module here. We call it ls minus ld os.py. And this one is, I'm going to run it using cat minus n first, os.py, so we can see the content of the file. And this one's supposed to import the OS module. This import directive in Python is telling it to load the OS modules, and then the functions and attributes will be available after that one. So when you say os.name, it's gonna say return POSIX because this is Linux or Unix. In Linux and Unix, it's going to have a value of POSIX, and Windows is going to have a value of NT. So since it is POSIX, the right command is clear. If it was NT, it would be CLS for clear screen. And then this print statement, disregard to the OS module name, it will work. Print is just a generic print function. And then this print statement is going to do a list of directories for the OS that's going to produce the output there. And then the second command is going to give me the help. But since the functions are going to be running, if I just say Python and then just say os.py, notice that if I just say os.py, it's going to know that that is the script. And that line before, it's already produced a dir, which I go up, it's all of those ones are there. And then if I just come back here, this is going to give me the help on the OS module. And then it's going to slow down one screen at a time so I can read it and then see all the functions that are available, all the other modules that are there. For example, the sys modules is also available inside the OS module, and sys module is a separate module as well. And then we're going to go inside the Python interpreter now to just see the same kind of functionality within these objects that we just run it. And before I do that one, let me quit out of this script that I just run. So I type in Q for none, quit, and then it clears the screen. I clear the screen and then I do ls minus l. Notice I wrote also two shell script, which is bash script. Now I say cat minus n p1.sh. On p1.sh, or instead of Python, I'm calling bash script. So if I type in which bash, and this is the bash interpreter, the shell that it's going to be spawned by the env method, or env binary. So the in this case, it's going to just do a hello from the bash script and then use a for statement for item 1 through 5, and then it prints the item. So in the bash script, I could type in and run it like a p1.sh like this to just run it, or I could just say bash minus x p1.sh. I could do that one also. And then bash minus x meaning run it in debug mode. So I could just see the command and then the output. The plus means the command. This is the command I'm doing. So cat minus n p2.sh is a second shell script that I wrote. Sorry, let me clear the screen. Cat minus n p2.sh. This one is basically a second script that uses also a for statement, but instead of item 1 through um, for a statement in sequence that earlier was just doing within braces 1 colon 5. This time I'm using the sequence. The sequence is just in bash. If I just say sequence 10, it will just print me 10 numbers. So it's a very useful command. If I just say sequence 1 to 10, then it's gonna just separate them between 1 and 3, and then 2 incremental by 2. If I just want to do incremented by, let's say 5, then it would be very small numbers. In this case, let's say 1 to 5. That would just do the same thing, 1 and 6, and then the next number is already bigger. But if I just want a lot of them, I could just maybe make at least make it up to 20. So 5 and then 20. So now we get 10, 11, and 16 because increment of 5. And then if I just start with 0, in this case, let's say start with 0, sequence of 0, and then that, you can see that it starts 0, 5, 10, 15. Now I have some numbers that are incremented by 5. Earlier was also by 5, but it started with the initial value of this. So this sequence is almost like a range value in Python. We can look at those one as well if we want to. But in this one, I want to show you the script. I'm sorry, I want to show you the Python module. So let me clear the screen. I'm going to type in Python in this case, and it's gonna drop me to the Python interpreter. But because I set my alias to point to 3.69, it is just spawn off 3.69. So at this time, if I just type in dir here, these are the kind of double underscore methods or done their methods, and also whatever built-in environment variables and functions and everything that's available for me, it will list it. And it's also the docs there. So I'm going to import one module called OS. By doing import OS here, I just imported OS module. So now if I just do a dir, in addition to those other previous one, I also see the OS module, which is here. In order for me to get documentation on OS, you can see this double underscore. I could just say print OS dot and double underscore doc. This will just give me all the documentation for the OS modules. Like for example, os.name. If I just type in os.name here, that attribute is gonna just return POSIX, which earlier we checked. And if I just do os.path, you can see that it shows the path. os.current directory, this will give me the current directory. And then os.separator, for example, is going to give me separator. So there's a lot of information here that we're going to check. Now we did that one. Let's just do a dir of OS. These are a list of all the functions and attributes and double underscore methods that are available here. If I go up here, because I'm inside the interpreter, it doesn't fit on one screen. It's a lot. So you can see dir OS is there, and these all and the uppercase functions that are available, the uppercase methods that are available, the uppercase um, attribute in this case, and then the lowercase function and attributes that are available. So what is my interest in this one is that we're going to do a couple of functions, or at least some of the functions within the OS modules. So let's just do one function and to clear my screen. This screen and right now has a lot of information. First, let's just do os.system, and then right here you can see I can do a clear, and it will clear my screen. Because I'm using the clear command, it is running the operating system clear command, so it just clears that screen for me. And if I just change the clear command to any Unix Linux command that I'm familiar with or know it, I can just get information based on the command I pass in to the system function calls. In this case, if I just did what I did earlier, uname minus a, this would just give me the operating system and details of uname minus a. Let's just put the n there. Uname, I'm sorry, and this thing is just keep moving around. Very uname minus a. So this one is 2A's 1A. Now you can see that the operating system uname minus a is giving that. And if I just say, go ahead, show me the current working directory, which is pwd. Print working directory, you can see that is there. And similarly, if I just say ID, like last time I did, say identify myself. Let's just type in ID here. You will see that it's wlutfi with user ID this. And then if I just run some of the command like cat minus n p1.py. So the content of p1.py should be displayed here. And similarly, if I just do the os.py, content of it. So everything that I could do here, like os.py. you can see that it is going to display those ones. And even like if I want to just make a copy of that directory, let's say I'm here under the sys module, and if I just want to see on this current directory what I have here, I could say file star.py, that similar to the way we looked at earlier and there. And if I just say get the statistic on the file on the any of those ones, let's just say I go and run the command stat to get the statistics on p1.py, let's say. And then you can run that one. It will give you the access modification, change time, modification time, access time, and then the inode blocks, and then the IO blocks, and then the name of the file p1.block, and then inode number, everything. So the earlier when I said ls minus li, let's say on the file stat, I could just say, since I did it on P1, I could also run this command on Linux to say ls minus li p1.py. And then I is for to show the inode number. And you can see this inode number is the same as the inode number that is displayed here. Sorry, and I have to highlight the right one. This inode number here is the same inode number here, and that is displayed. So I could also run the os.system with every other command that I want to do. Like for example, let's say I could say run the env, and then do a grep minus I on pwd that we did earlier. So if I just run that command, I know that my current working directory is pwd. Now, there's other function aside from OS. You can do other function like os.get current working directory. So this would return the current working directory. You can see that that's returning the same one. Or os.get environment, and then type in the environment variable that you want to be getting output from, like let's say path, or let's say you go pwd. So if I just change that one to pwd, but pwd is, as you can see, is uppercase. It is case sensitive. It's going to return the value of pwd from by getting and if I do a lowercase, it's not going to return. As you can see, it is case sensitive. So it's important to type in the right case. Now let's do a lowercase pwd, and you will see that it doesn't return any value because that variable is not set. But if I do an export and say, well, let's say I just do on the system, I want to set my pwd lowercase also to, because lowercase is actually a command. So it's not a good idea to just set up a command to and just be a variable in this case there. Otherwise, if you just say, for example, let me just do a system, and then and instead of pwd, I'm gonna just say export, and I'm gonna say export. Export is the in bash is exporting an environment variable like pwd or something, or path or something. So I'm going to create a directory called x in uppercase, just that doesn't exist. But then I'm going to assign the content of the pwd, the current directory. So if I just do this, and then I just run the backtick, and then I say, and the output is pwd. So this might just set up the environment variable x. Now, if I just do os.get env, and then I just run the x in uppercase to see if that variable has a value, it doesn't. But let's just say, instead of that, I'm going to say what I exported here, I'm going to do echo on $X to see if that variable was set properly or not. So here I'm going to do echo $X. And $X was not set. You can see that, oh, system, I have to do M here. Somehow it was deleted, the M. Let's just move there. And then we run that. And now you can see the X was not set. And there, the value of it was not set. And so if you set the value and it takes the arguments there, because we did it within the system, it did not take it. But if we do it inside the bash itself, it will take it. So I'll show you how we set up that one. Let me just exit out and show you that one. And so if I just here say, for example, I'm on bash, I'm going to just clear screen and say export X is equal. And then I use the backtick and run the pwd command. Now I just say enter and then say echo $X. It's gonna lowercase is not defined, but uppercase is defined. So you have to do case sensitive. For some reason, let's just type in. Okay, so now you can see that runs the output of it. It's there. The environment variable is getting executed, the pwd. And if I change that one to show another command, like for example backtick or do a ls minus ld, so let's do either even backtick or $, and then parentheses, and I could say ls minus ld star.py. I could do that one too, and it will still do it. So now if I just run export echo $X, it basically gave me a list of the files in uppercase, not lowercase. This one. Oops. It just changed it for some reason. X. Yeah, that one. And that one will list it. So let's go back to Python and then do some more of the OS modules. So if I just do a Python here, it's gonna drop me to 3.6 and then do another dir because I logged out. Not OS is not loaded anymore. The interpreter, as soon as you exit out, it unloads those that were loaded after by running import command. So I'm going to do another import OS, and then if I just say os dot get env, and then now let's just get the environment variable of pwd. We did that one earlier. Let's just get the old pwd. So this one, any variable that is set, you will get the value of it by getting the get env. For example, home and home directory where the what it is, and you just type in home, and you will get the home wlutfi directory. So another one is important is that, for example, os dot get UID for the current user ID. So as you can see, like os.system, and then if I was typing ID here, you could see that, okay, it shows that my user ID is wlutfi. And then get UID is equivalent to UID on the command ID itself if you want to just get the ID. ID dash u, oops, sorry, keyboard is funky. ID dash u. Okay, so ID dash u give you the user ID, and get UID in Python and did the same thing. As you can see, the get UID. So if I want to do ID dash G and dash G, and instead of dash U, that should give me the group ID. So let's try that one, dash G. ID dash group ID is also 1000. So now if I want to get it inside Python with get env, um, was it get no was a get UID. So I'm going to do a get UID here. Let's just go back to get UID, and instead of get UID, I'm gonna get GID for group ID. So that function is also available here by typing get GID, and that also gave me the same thing. And then now, if you remember, we could say os.stat also get the statistic on os.py, for example, os.py. And then now, if I want to run inside Python interpreter, I could also call it like say os.system. Let's just clear the screen first, and then run the command here. And instead of clearing the screen this time, I'm going to run the um, script, bash script, bash minus x, and then we could say p2 dot sh. So p2 dot sh will run, as you can see, because I'm running minus x, it runs it in debug mode. It has the plus in front of it and everything. So at this time, if I want to just run it without the x and not in debug mode, I could do that so as well, without the space here. I have to give a space. Somehow, as I say, the keyboard is just jumping back and forth. It's killing me. Sorry about that. Okay, let's just, I'll fix this keyboard issue next. So right now you can see that bash p2.sh is working. And then similarly, if I just run it from the command line, I could also run it this way with, because the permissions are set, I don't need to put bash in front of it, because on the first line I have the shebang user Benny and B, and then bash, it will know that this is a bash script, and it does say hello from the bash script. So some of these functions are there, some of the less thing. If I want to get, for example, list dir, list dir is going to give me a list of directories that are there inside the files and directories that are open. And then if I just say let's say system, I could just say make dir minus p, meaning that create dir1, and then inside of it create dir2, those kind of directory, and dir3. Now I have a 3 level of directory with just by specifying dash minus p option. The path, if it doesn't exist, dir1, dir2, it will create it as long as everything is with the dash p option there. So I could do the list dir again, and then this one is going to list the dir1 also, because dir1 is there. But if I want to do list content of dir1 only to see what is inside dir1, I could just within this, I could say list dir, but then I have to dir, and then I have to say dir1 inside there. So I only see dir1 in this case. And then inside dir1, I could say give me the dir2 also. Inside dir2, what do you have? It's dir3. And then I could just say, let's say rm dir. I could do a remove directory here, rm dir, and instead of list_dir, I could also rename it. So let's just do a os.rename, and then in this case we're going to, let's say, um, let's say we call it P1 sorry, it is hard to type. So basically, let me just show you how to get help on the functions. So if you just say, for example, os.dot rename, rename, and then inside the directory, you say p1.py to uh, p1.py.back. Let's say we just name it as a backup, rename it. Oops, I had two codes here, and somehow the keyboard and just kicked in after. So now it did that one. So now if I say os.list_dir, you can see that the directories p1 got renamed to p1.p1.back because I gave it as a name like that. And if I just want to rename that one again, this time I have to say os.rename, and then say I want to rename p1.p1.back to back to p1.py, and that would be sufficient enough to just do that one. And when I do the list_dir, it is showing that p1.py is there. So now by renaming, it did not change any content of it, it just renamed the file name. So if I just say os.system and then say cat -n p1.py, the content is integrity was not touched. So you can see it is the same script. And if I run it, it's the same, everything the same. So now I'm going to do another modules by doing print help. And then let's get the os.sys module. os.sys module is inside the os module, and you can see that it has a lot of other functions and arguments, argv and path, and os version, sys version, standard in, standard output. There's a lot of functions and variables and methods that are available with attributes that you're using it. So for example, if I just go to the list, there's a lot, but let's just do this. A quick os dot, so os dot sys dot __ doc __ doc. This would give me all the documentation for the os module. And if I just do a nice printout of it, say os dot sys dot and double underscore and doc, the under method, and then you can just run that, you will get the os module. You can see that the exit functions, the get trace, and then display hook, and a lot of them, those ones. So let's get the dir of os.sys to see what are the list of functions and attributes that are available. Here are the list of the dir os.sys. And as you can see, if I do a type on the os module, the type is going to show that this is a module and it's a class type, because the same thing will do the same thing with os.sys. os.sys will do the same thing. It's a class module. And inside the class os.sys module, all these functions and attributes are there. So some of the attributes like version. So if I could just say os.sys.version, it shows me the Python version. In this case, is Python 3.69. And then if I want to get more details of it, and I could say os.sys.version_info for information and details of the version. And then it has other functions that you could do, like for example os.path and then you can see the path to the Python information. And you can say os.executable. Those ones are executable. So let's see if the executable, I'm going to do another dir here just to show you os dot, it is, yeah, type is there. We need the dir os dot sys. So you can see here, and then let's see the E for the, so you can see the characters that are available here, get, E, exception, and then here is executable. So if you type in os dot executable, it shows you the os dot execute, oh, executable, sorry, keyboard, stop it, os dot executable. It's just not allowing me to get it. So let's get the os dot executable to see if this one is returning a, it should show the, I'm going to do print, oh, sorry, you don't say os dot executable, you say os dot sys dot executable, because we are inside the sys module. So let me clear the screen first. There's a lot of trash here, not good information. System, oh, os.system, and then clear the screen first. Now I'm going to do os.sys.executable. If you just type in os and dot executable, there's no such attribute, but os.sys dot executable will return you the user bin Python version that is we're running the executable. So there's a lot more details on these ones, and you can also import the OS, I'm sorry, the sys module if you want to just do it separately, and that is same module with more information inside. You don't need to do all these things that are available. You don't need to put OS in front of it. So you could say sys.version, it will give you the same thing, sys dot execute executable, sys dot executable. You have to type it correctly, and then so on. I mean, sys dot PS1 for prompt shell 1, PS2 what is defined. In this case is for Python, the there sys, for example, if you passed in any argument, sys dot argv, and then argv sub 0 and argv sub 1, if there's any parameters that are passed on to them, you will get a lot of those details. Sys dot path, did I do that or already? Maybe I did. So you could see the Python executable, and then in addition, you can get other functions from dir of OS, for example, to see if you want to be replacing something. If you forgot some of these commands and the command lines, you can also type in help on the as a function on the Python interpreter, and you will get a help menu. If you just type in OS here, you will get all the OS modules and functions. Similarly, if you just quit out of here and then you say a plus, for example, to get the operator plus symbol. So help is really good. If you just want to do os.sys module, you can get that information. If you get let's say help on os.system, you could get that as well. So everything that is there, if you're interested in, like, for example, os dot get current working directory, let's say, that is going to tell you the help on it that says that it returns this one. Or os dot and get group ID and group ID. So if you just do get group ID, so that is of another function that you can just get group ID, that D is missing here. Now it's working. So you can get any of the details here. I hope that is going to be good enough for you to get started with the OS module in Python and get the detail. In order to get out of the help, you just press enter, you're dropping back to the Python interpreter. So here you can just do a os.system, clear the screen. Let's just do a quick if statement with checking the os.name. For example, os.name is POSIX. So if I want to check that if it is there, run a clear command. If it is an NT Windows machine, then run another command. So now I say if os.name is equal, and then I put the word POSIX. You have to type in exactly that case sensitivity because it's going to compare it. And then you're going to put a colon for separators for quote blocks. So instead of begin and then like other languages, and you're just moving four characters to the right from this one, indented, and then say, let's say we're going to do os.system, clear the screen, and then once you use the clear screen, you just are basically done with this. Now else after I clear the screen, in fact we are going to do a print statement, print say Unix or Linux POSIX portable operating system information exchange was detected. So this information will be printed after the clear the screen. And then here I'm going to do an else part. And then on the else part, you put a colon and then you say print. Let's say this one, we assume that if it is NT, we didn't check for os.name is equal NT. We just say that it must have been another OS type because it was not Linux or Unix, but it was. So in this case, it's POSIX. It's going to just print, clear the screen and print our statement. It doesn't go to the else part. And if I just press enter here, it's going to go to the next line. But once you press the next enter, it's going to execute the clear command, and it says Unix or Linux POSIX was detected. So with that, we're going to end this by running exit and just give you a long listing of the files that were here as we do. And then just to list you these ones, let's minus L dir one, you can see these files are there. I'm going to do rm minus rf dir one and get rid of all the directories that was empty subdirectories. Now we have empty directories. Be very careful with rm minus rf when you're doing it. Make sure that you double check it and intentionally you don't want to delete something recursively. The minus R stands for recursive and F means force it. Don't prompt me. So you have to be very careful on that one. You have a lot of other options with this one. On my other bash and Unix shell scripting, I'll show you those ones. So please don't forget to subscribe. Please go to the end of our video and you will see the subscription. And the more you people subscribe, the more it encourages me to make better videos for you, for your education. All my videos will be posted on YouTube, and it will be available for your use for free. As you know that subscription free and education, you can learn all of that one for free. Enjoy it. Have a nice one. Thank you so much for all of you guys. I hope everybody enjoys it, and subscribe as many as you do so you can get all the details as I posted, the latest one as I posted. Have a nice one. Bye.